This dinosaur killer is one of the most misunderstood dinos of all time. The real-life Velociraptor was a dromaeosaurid theropod dinosaur that roamed the Mongolia-China border during the Late Cretaceous period. Now, contrary to its cinematic portrayal, this guy was no larger than a wolf and boasted a bird-like appearance with its feathered covering. But wait, since it had feathers, does that also mean it could fly? Stick around to find out. The very first Velociraptor fossil was found in 1923 during an American Museum of Natural History expedition in the Gobi Desert. This desert is in southern Mongolia and parts of northern China, and back then it was one of the most remote places on Earth, only reachable by reliable vehicles and trustworthy horses. Despite its isolation, the Gobi Desert held great potential for dinosaur fossils. Roy Chapman Andrews led this adventurous expedition into a desert area called Jadokta. In 1923, his team found the first ever nest of dinosaur eggs. During these expeditions, the team stumbled upon the Velociraptor. They discovered an impressive claw alongside a complete, although crushed, skull. The claw, about 176 millimeters in length, was initially thought to belong to a different dinosaur. However, the president of the American Museum of Natural History published drawings in 1924 declaring it was a claw from a new dinosaur and named it Velociraptor mongoliensis. This translates to speedy thief from Mongolia or quick plunderer. Osborn recognized the dinosaur as a swift predator, and the name Velociraptor, a combination of Latin words meaning swift and thief or plunderer, quickly became the official name. There are two known species of Velociraptor. The first one, Velociraptor mongoliensis, was discovered in the Gobi Desert back in 1923. The second one, Velociraptor osmalskae, was identified in 2008. Now, what sets these two species apart? Well, there are many similarities, such as a large teardrop-shaped hole in their skulls. However, enough differences were found in the serration and structure of their teeth to classify Velociraptor osmalskae as a distinct species. This discovery raises interesting questions for paleontologists. Why did two different species of Velociraptor develop? Well, it could be due to slight differences in plant life between the Bayan Mandahu and Jadokta formations. There's a theory that the two species lived at the same time, but were separated by some geographical barrier. The Velociraptor was quite small for a dinosaur, usually measuring around 6 feet, 1.8 meters long, and weighing less than 100 pounds, 45 kilograms. Its body was streamlined and lightweight, designed for swift movements, which made it a skilled predator. With its long, narrow head and relatively large brain, it had a sleek appearance, and its snout was somewhat flat. Its jaws packed rows of sharp, jagged teeth, perfect for tearing through flesh. In 2007, scientists confirmed that Velociraptor sported feathers, adding an interesting dimension to its appearance, and likely helping it regulate body temperature or display for mating. However, despite the presence of feathers, its arms were too short to facilitate flight, so it probably remained firmly grounded while chasing prey. Now, the Velociraptor was a bipedal dinosaur, meaning it walked or ran on its two hind limbs standing upright. Its legs were strong and ended with the iconic sickle-shaped claw on the second toe of each foot. This claw was incredibly flexible. Initially, scientists thought Velociraptor used this claw to slash open its prey in one swift motion. However, further studies suggest it was more likely used for stabbing and gripping its victims, similar to how modern birds of prey use their talons. The sickle-shaped claw was held high while the dinosaur moved, probably to keep it sharp and ready for action. Its forelimbs were relatively long and ended with hands capable of grasping, each sporting 3 clawed fingers. The tail, rigid due to bony rods along the vertebrae, helped Velociraptor maintain balance while running or attacking prey with its single-shaped claw. This guy's speed, agility, and lightweight build made it a formidable predator, capable of some pretty quick moves when chasing its prey. These qualities earned it the name Velociraptor, meaning quick plunderer. It primarily hunted small plant-eating dinosaurs, often launching surprise attacks from the cover of vegetation. Due to its size, it preyed on small mammals, reptiles, amphibians, and insects, opting for anything that was easy to overpower and kill. Additionally, they occasionally targeted small infant dinosaurs, like young protoceratops, baby oviraptors, and little prenocephalae, showcasing their opportunistic feeding habits in their local ecosystems. Like all dinosaurs, Velociraptor likely reproduced by laying eggs. It probably stayed with its nest to protect its eggs and offspring. Fossils of another meat-eating dinosaur, Oviraptor, found in a nest with eggs and young, have sparked debates among paleontologists about parental care among dinosaurs and their close relatives. The potential mating behavior of this species might have involved displays of size, gestures, vocalizations, body language, and perhaps even synchronized dances between mates. Moreover, the Velociraptor possessed numerous sharp, pointed teeth in both its upper and lower jaws, lacking a beak seen in some dinosaur species. These teeth featured intimidating serrations with sharp edges on each tooth, intensifying from the front to the back of its mouth. To maintain its sharpness, Velociraptor's teeth were continually replaced throughout its life, similar to the Tyrannosaurus rex. Additionally, the teeth of the Velociraptor curved backward, providing a practical advantage for gripping prey and preventing its escape. The narrow jaws and compact build suggest a preference for smaller prey, confirming the carnivorous nature of the Velociraptor. Now, this amazing creature had a robust skull, relatively large for its size, at approximately 23 centimeters or 9.1 inches. Its box-like skull featured a long, narrow snout, constituting about 60% of the entire skull, ideal for capturing swift prey with quick, snappy bites. While popular culture such as Jurassic Park portrays velociraptors as highly intelligent creatures capable of opening doors, their intelligence likely paralleled that of an average cat or dog, falling short of the intellect attributed to dolphins or primates. This assessment is based on the encephalization quotient, which compares brain size to body size, indicating relatively high brain size in velociraptors compared to other animals, including dinosaurs of the time. There are also indications suggesting velociraptors might have been nocturnal. This is supported by the presence of a large sclerotic ring, which is a bony ring inside the eye socket that typically accommodates enhanced night vision by allowing more light into the eye. There's research suggesting that predatory dinosaurs like velociraptors and microraptors were primarily nocturnal, with exceptions like cathameral dinosaurs, which were active in short bursts during the day. This theory aligns with the behavior of modern carnivores, most of which are nocturnal. While ongoing studies continue to reveal more about this research, it sure as heck challenges the conventional portrayal of dinosaurs hunting and living predominantly in broad daylight. In reality, the dinosaur world may have functioned around the clock. Velociraptor, along with other carnivorous dinosaurs from Central Asia during the Late Cretaceous period, were adorned with fine feather-like coverings. Paleontologists have compelling evidence supporting this conclusion, and it's not exclusive to Velociraptor alone. Close relatives like Microraptor and the Congoraptor also exhibited feathers. In 2007, a Velociraptor forearm specimen revealed imprints of quills, indicating the presence of 14 long feathers extending from its second finger to its arm. These feathers likely served to regulate body temperature. Furthermore, Velociraptors might have employed their wings to shield nests, like some of our raptorosaurs found fossilized in protective positions over their eggs. Wings could also have helped manage nest temperatures and facilitate quick maneuvers, generating speed on inclines through negative lift. Feathers might have also been used for display purposes, potentially attracting mates, similar to modern birds. Now, while velociraptors possessed fused wishbones and collarbones, resembling those of modern birds, their wings weren't suitable for flight due to their symmetrical nature and insufficient size to support the dinosaur's body weight. But there are some studies that suggest velociraptors may have had ancestors capable of flight. However, they probably lost this ability through evolution. This scary little dino came equipped with a lengthy tail, and it probably utilized this feature to maintain stability while running at high speeds. The tail, comprised of rigid fused bones, acted as a stabilizing mechanism during the velociraptor's pursuits and hunts. Contrary to the traditional belief that the tail was inflexible, a recent specimen displayed intact vertebrae arranged in an S shape, suggesting a degree of flexibility. With muscular legs and its impressive tail, estimates suggest that the velociraptor could reach speeds of 40 kilometers per hour or 24.85 miles per hour in short bursts. This velocity surpassed that of humans and its potential prey, adding a formidable aspect to its hunting prowess. However, it's noteworthy that while Velociraptor was swift, It did not hold the title of the fastest dinosaur. Ornithomimosaurs, likely running in a manner similar to ostriches, are estimated to have achieved speeds of 70 kilometers per hour or 43 miles per hour. There is minimal evidence supporting the idea that velociraptors or any dromaeosaurs engaged in pack hunting. The concept of pack behavior in hunting is a sophisticated behavior observed in very few mammals, as mammals in general are considered intelligent. The common depiction in paleo art of large dinosaurs being instantly besieged by groups of Deinonychus is not well supported. The basis for this notion comes from a bone bed where several Deinonychus individuals were found grouped together, apparently feeding on a deceased Tenontosaurus. This could indicate group hunting, but it's also possible that the prey animal died from other causes and unrelated Deinonychus opportunistically gathered to feed. Considering the nature of these dinosaurs, the latter scenario seems more plausible. When we look at how these dinosaurs behave, it seems more sensible to think that they were competing for food rather than hunting in packs. Even though we might be tempted to link intelligence with pack hunting, it's not so clear when it comes to raptors like Velociraptor. In Jurassic Park, the idea of smart raptors challenges the old beliefs that all dinosaurs were not very smart. People used to think dinosaurs were dumb because they were considered reptiles, and reptiles were usually not seen as very bright. But dinos like Velociraptor and others faced a bit of a bias. Scientists named parts of their brains like mammals, making it seem like they used less smart structures. It might sound confusing, but it just means that they assumed birds and some dinos, like Velociraptor, used simpler brain structures for thinking. So, the idea of super smart raptors doing complex things like hunting together still needs more proof. There are a few ways to guess how smart animals might be. We can check their brain-to-body ratio or count their neurons, but these methods aren't perfect when predicting intelligence. They mainly give us general ideas, and with animals that lived a long time ago, it's even trickier because we can't directly test how smart they were. This is why Jurassic Park made a point of including intelligence as a mystery. We had no way of knowing how clever dinosaurs really were going to be. Looking at the brain case of Velociraptor, it's been studied, and it seems quite similar to what we see in Archaeopteryx. We can say that more of their brain was used for smelling compared to birds, and they didn't have a specific structure for processing visual and touch information, which makes sense since they couldn't fly. However, when it comes to their problem-solving skills, it's something we might never know for sure. In the end, the Velociraptor, with its sharp, serrated teeth, feathered coverings, and vicious jaw, thrived in the diverse, fossil-rich landscapes of Central and Eastern Asia. As a warm-blooded, agile predator, this relatively small dino utilized its speed and intelligence to hunt small prey and survive in dry environments. And that's a wrap. Do you think, despite its small wings, the Velociraptor could still take small flights? Drop your thoughts in the comments below. And if you enjoy learning about ancient creatures, make sure to hit that subscribe button and stay tuned for more cool stuff about the past.